Welcome to a tutorial on solving quadratic equations, presented by the Regent University Math Tutoring Lab. In this tutorial, we will cover the steps for solving quadratic equations. First, we will discuss key terms for quadratic equations. Second, we will examine special cases of quadratic equations that are easier to solve than others. Third, we will learn the four main methods for solving quadratic equations. Finally, we will look at the steps that are unique to each of these methods. First, we need to define a few key terms. A quadratic equation is any equation with a single squared variable as its leading term. In other words, the variable raised to the second power should be the one with the highest power. The general form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are numbers. We call these numbers coefficients. A root is a solution to an equation. Quadratic equations have two roots. Sometimes each root is unique, and sometimes a single root is repeated. Plugging each root into the equation, one at a time, should always result in a balanced equation. The next thing we want to look at is a couple of special cases of quadratic equations that are easy to solve when we recognize them. The first case is when a quadratic is a difference of two squares. In this form, ax squared and c are both squared, and a equals 1 and b equals 0. Also, c is subtracted from ax squared, which gives us the difference of two squares. The roots in this case are the square root of c with opposite signs. Another special case is when our equation is a perfect square. This occurs when a linear binomial is squared. The solution to a perfect square is a single repeated root. The root is positive for perfect squares with a negative middle term, and negative for perfect squares with a positive middle term. We also need to remember that every root we find should be left in its most exact form. If we're ever left with a square root that doesn't result in an integer when taken, we should leave the smallest number possible under the radical. If an equation has a leading term where a is not 1, some methods of solution will work better than others. Now we want to look at four useful methods for solving equations. Some equations are better suited for a particular method, while some can be easily solved by any of the following methods. We will learn to solve by factoring, by using a square root, by completing the square, and by using the quadratic formula. First, let's look at solving by factoring. This method is fairly easy if your equation has integer roots. To factor, we need to arrange our equation into the standard form and factor the left side into two linear factors, each set equal to 0. To solve, isolate the variable in each of our factors. The results are our roots. If an equation doesn't look like it'll factor easily, then another method might be needed. The second method at our disposal is the square root method. If our equation does not have a linear term, in other words, b equals 0, then we should isolate the quadratic term on the left side of the equation and take the square root of each side. The result should resemble x equals plus or minus the square root of our constant term c divided by our coefficient a. If we can take the square root of this, we should do so. If not, then we want to leave the right side in its simplest form possible. If we have a linear term, but our equation doesn't look like it factors easily, we can try to complete the square. This method works best when our leading coefficient a equals 1 and b is divisible by 2. Once our equation is in standard form, we need to add a number we will call d to each side of our equation. We find this number d by dividing b by 2, squaring the result of that, and then subtracting c. After we add d, we need to factor the left side and use the square root method on the binomial squared we got from factoring. After taking the square root of both sides, isolate the variable on the left. The numbers left on the right are our roots. Our last method for solving quadratic equations is using the quadratic formula. We saved this method for last because, while it guarantees that we'll get an answer, it also takes the most work. First, we need to arrange our equation in standard form. Then, we want to write down our values for a, b, and c, including the signs that precede them. Now we need to write down the following formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. It's a good idea to memorize this formula so you always have a way to solve quadratic equations. Now that we have our formula written, we need to plug in our specific values for a, b, and c into the formula in place of the corresponding letters. We need to use parentheses when doing this to make sure that we don't mess up our signs when we plug in. Now that we have only numbers on the right side of our equation, we can use the order of operations to find our solution. Our solutions depend on what we have under the radical. If this result is positive, then we have two distinct roots. If it is 0, then we have a single repeated root. Now let's look at the process to complete each of the methods we just learned. The first thing we need to do is choose the best method of solution. We do this by inspecting our equation. If our leading coefficient a is 1, then we should try to factor. If our linear coefficient b is 0, we should try the square root method. And if a is 1 and b is even, we may want to complete the square. If none of these are the case, or we try one of these methods and it doesn't work, we should use the quadratic formula. Factoring, completing the square, and using the quadratic formula all require our equation to be in the standard form, ax squared plus bx plus c equals 0. The square root method is easier if we set our equation up so that x squared equals c divided by a. After we apply the steps for a given method, we can check our answers by plugging the roots we got back into the original equation, one at a time. Now let's solve a quadratic equation. We are given the equation x squared plus 10x equals 11. Based on a quick look, we can probably try to factor or complete the square. Let's complete the square for this problem since a equals 1 and b is even. First, we need to put the equation into standard form. We do this by subtracting 11 from both sides of our equation. This result is x squared plus 10x minus 11 equals 0. Next, we need to find the number d that we're going to add to both sides. We get this by dividing our 10 by 2 and squaring the resulting 5. This gives us 25, from which we need to subtract a negative 11. This results in 36. We add 36 to both sides of our equation, giving us the equation x squared plus 10x plus 25 equals 36. Now we factor the left side of our equation. This produces the factor x plus 5 times the factor x plus 5, or x plus 5 quantity squared. Now we take the square root of each side so that we are left with x plus 5 equals plus or minus 6. We isolate our variables by subtracting 5 from both sides of our equation, giving us x equals plus or minus 6 minus 5. Positive 6 minus 5 gives us a root of 1, and negative 6 minus 5 gives us a root of negative 11. To check these roots, we plug them into the equation one at a time. Plugging in 1 gives us 1 squared plus 10 times 1 equals 11. This is the same as 1 plus 10 equals 11, which is correct. Plugging in negative 11 gives us negative 11 squared plus 10 times negative 11 equals 11. This equals 121 minus 110 equals 11, which is also correct. Let's try another example using a different method. We're given the equation 2x squared plus 4 equals 7x. Since we have a linear term, we need to put our equation in standard form, regardless of what method we use. We subtract 7x from both sides to produce 2x squared minus 7x plus 4 equals 0. Since we have a leading coefficient other than 1, let's use the quadratic formula. First, we set our numerical coefficients equal to their letter counterparts. Here, a equals 2, b equals -7, and c equals 4. Next, let's write down our quadratic formula and insert our numbers in place of the letters in the formula. Using parentheses, we have x equals minus -7 plus or minus the square root of -7 squared minus 4 times 2 times 4, all divided by 2 times 2. Now we use the order of operations to find our roots. First, we square -7, giving us 49. Second, we multiply our negative times our -7, giving us a +7. Then, multiplying 4 times 2 times 4 gives us 32, and 2 times 2 gives us 4 in our denominator. This gives us x equals 7 plus or minus the square root of 49 minus 32, all divided by 4. Subtracting under our square root gives us x equals 7 plus or minus the square root of 17 divided by 4. Since 17 is a prime number, we will not be able to break this square root down further. Because of this, we leave our roots as x equals 7 plus the square root of 17 divided by 4, and x equals 7 minus the square root of 17 divided by 4. Approximately, our roots are 2.78 and 0.72, but plugging these numbers into our equation won't quite balance it, so we'll leave them in the form that includes the square root. Thank you for taking the time to learn about quadratic equations and for making the most of your Regent experience.